In this lesson, we will explore the connection between artificial intelligence and sustainability, and understand why this topic is becoming increasingly important in today's world. Artificial intelligence is a technology that allows machines and computer systems to learn from data, recognize patterns, and make intelligent decisions. It is used in many areas of everyday life, including search engines, social media recommendations, virtual assistants, healthcare systems, transportation, and even climate prediction. As AI continues to grow rapidly, it is becoming an essential part of modern society and plays a major role in shaping how we live and work. AI allows computers and machines to learn from data and make decisions in ways that are similar to human thinking, but based on mathematical patterns rather than emotions or intuition. Instead of being explicitly programmed for every single task, AI systems are trained using large amounts of data so that they can identify patterns, relationships, and trends within that information. Over time, they improve their performance by learning from examples, mistakes, and feedback. For example, AI can recognize images by analyzing thousands or even millions of labeled pictures to understand what objects look like, such as distinguishing between cats, dogs, or cars. Similarly, AI can predict results by studying past data, such as forecasting weather, recommending videos on streaming platforms, or predicting stock market trends. This ability to learn and adapt makes AI extremely powerful and useful in many real-world applications. Sustainability means using resources such as energy, water, materials, and technology in a way that meets our current needs without reducing the ability of future generations to meet their own needs. It is about finding a balance between development and environmental responsibility, ensuring that progress today does not create long-term damage to the planet. In simple terms, sustainability is about using what we need carefully and efficiently so that natural resources are not wasted or exhausted. This concept is especially important in a world where technology and industries are growing rapidly. Every digital system, including artificial intelligence, cloud computing, and large-scale data processing, requires electricity, hardware, and infrastructure to function. If these resources are used without control or efficiency, they can lead to problems such as high energy consumption, increased carbon emissions, and depletion of natural resources, like water and minerals used in manufacturing hardware components. Training large AI models consumes a significant amount of electricity because the process involves running powerful computers, such as GPUs and specialized AI chips, for long periods of time on massive datasets. During training, the model repeatedly processes information, adjusts its internal parameters, and improves its accuracy through millions or even billions of calculations. All of this computation requires continuous energy, which can add up to a very large amount depending on the size and complexity of the model. When this electricity comes from non-renewable energy sources, it leads to the release of carbon dioxide and other greenhouse gases into the atmosphere. These emissions contribute to global warming and climate change, which are major environmental challenges today. Larger AI models generally require more computing power, which means more electricity usage and potentially a larger carbon footprint if the energy is not sourced responsibly. AI systems require computers and servers to process large amounts of data, and when these machines operate continuously at high speed, they generate a significant amount of heat. If this heat is not properly controlled, it can damage the hardware and reduce the performance and lifespan of the systems. Because of this, data centers, which host AI systems and cloud computing infrastructure, need effective cooling methods to maintain safe operating temperatures. One common method of cooling involves the use of water-based systems. Water is very effective at absorbing and transferring heat away from servers, which helps keep the equipment stable and running efficiently. In many large data centers, water is circulated through cooling systems or used in cooling towers to remove excess heat generated by thousands of machines working at the same time. We can design efficient AI models that perform well while using significantly less energy and computing power by focusing on how the model is structured, trained, and deployed. Instead of building extremely large and complex systems that require massive computational resources, researchers aim to create smarter and more optimized models that achieve similar levels of accuracy with fewer calculations. Efficient AI models are designed to reduce unnecessary complexity, This can involve using fewer parameters, simplifying network architectures, and removing redundant computations that do not contribute much to the final output. By doing this, the model becomes lighter and faster, which means it can run on less powerful hardware and consume less electricity during both training and inference. Model compression is a set of techniques used to make AI systems smaller, faster, and more efficient by reducing unnecessary or less important parts of the model without significantly affecting its performance. In large AI models, there are often millions or even billions of parameters, and not all of them contribute equally to the final output. Some parts of the model may be redundant or have very little impact on accuracy. So model compression focuses on simplifying these structures while preserving the most important knowledge the model has learned. There are different ways to achieve model compression, such as pruning, quantization, and knowledge distillation. Pruning removes weak or less important connections between neurons, effectively cutting parts of the network that are not needed. Quantization reduces the precision of numbers used in calculations, which makes computations faster and less resource intensive. Knowledge distillation involves training a smaller model to imitate a larger, more complex model, allowing it to achieve similar results with far fewer resources. By applying these methods, AI models become lighter and require less memory, less processing power, and less energy to run. This makes them more suitable for real-world applications, especially on devices with limited hardware like smartphones or edge devices. Edge computing is a way of processing data closer to where it is generated, instead of sending all the information to large centralized cloud servers for processing. In traditional cloud computing systems, data from devices such as smartphones is sent over the internet to distant data centers, where it is analyzed and then sent back. This process can take time and also requires continuous network communication, which consumes energy. In edge computing, however, the processing happens locally on the device itself or on nearby small-scale servers. This reduces the need for constant data transfer to the cloud, which helps lower network traffic and overall energy usage. Because the data does not have to travel long distances, the system also responds much faster, reducing delay or latency. This is especially important for real-time applications such as self-driving cars, smart assistants, healthcare monitoring devices, and industrial automation systems. Training AI models requires huge computing power because the system has to process massive amounts of data repeatedly in order to learn patterns and improve its accuracy. During training, an AI model adjusts millions or even billions of internal parameters through continuous calculations, comparisons, and updates. This process is computationally intensive and often requires specialized hardware like GPUs or TPUs running for long periods of time, sometimes days or even weeks depending on the complexity of the model. Because of this high demand for computation, training AI models consumes a large amount of electricity and can significantly contribute to energy usage in data centers. If the energy used is not from renewable sources, this can also increase carbon emissions and environmental impact. As AI systems become larger and more advanced, the cost of training them grows even more, making efficiency an important concern. Improving training efficiency means finding ways to reduce the amount of computing power and time required while still achieving strong model performance. This can include using better algorithms, reusing pre-trained models, optimizing data processing methods, and avoiding unnecessary computations during training. By making training more efficient, we can reduce energy consumption, lower operational costs, and make AI development more environmentally sustainable. In the future, artificial intelligence is expected to become much more efficient, meaning it will be able to perform powerful and complex tasks while using significantly less energy and computing resources than it does today. As technology continues to advance, researchers are developing smarter algorithms, improved hardware, and better optimization techniques that allow AI systems to deliver high performance without requiring extremely large amounts of electricity or processing power. This increased efficiency is important because AI is being used more widely in areas such as healthcare, transportation, education, and scientific research, all of which require fast and accurate decision-making. By reducing energy consumption, future AI systems will not only become faster and more cost-effective, but also more environmentally friendly, helping to lower their carbon footprint and support global sustainability goals. Artificial intelligence and sustainability are closely connected in today's rapidly advancing technological world. While AI has the power to transform industries, improve decision-making, and solve complex global problems, it also requires significant amounts of energy, computing power, and resources to operate. This creates important challenges such as high electricity consumption, carbon emissions, and water usage in data centers, which must be carefully managed. The future of AI should focus on balancing innovation with responsibility. By designing smarter and more sustainable AI systems, we can continue to benefit from technological progress while also protecting the environment.